Hi guys, my name is Mr. Weiser. I'm going to be going over our first lesson in the course. We're going to be talking about understanding the basics of function notation, evaluating, and finally transforming functions in the coordinate plane. This first video is going to be talking about the example one. We're going to be looking at how to map a function, determining if a relation, which is just a set of x and y values, makes a function, and then talking about what a one-to-one function is and how to recognize it. Let's get started. So first, just in general, a function is any group of x and y values, or just in general, when you input something in and you get something out, where each unique x value goes to only one y value. So what we're looking at is we want to look at the x values, really. We want to say, do we have any repeating x values? So if I look at here, I have a 2, 3, -1, and 2. Now, I'm not going to write the 2 again because it's just repeating itself. So I'm going to go over here and I'm going to write 5, -4, 2, and 1. Those are all different. Now, what happens is that 2, that goes to 5. That 3 goes to -4. So far, so good. -1 goes to 2. So all my x values here go to y value, but then I have this last one here where it has 2 going to 1. Now, what you got to recognize is that's an illegal move. We can't have this x value go to 2 separate y values. So let's look at what that looks like as a graph, okay? What you're looking at is a graph. If I'm plotting the coordinate 2, 5, that'll be about right there. If I'm plotting the coordinate 3, -4, -1, 2, and 2, 1. Now, the problem with this is that these 2 points right here, if you drew a vertical line through them, it would hit them both, right? And so this actually fails the vertical line test. So one way that you can tell by graphing is if you just have 2 points on top of each other that have the same x value but different y values, it fails the vertical line test. And coupling that with this going to 2 different y values, that's not allowed. So we would say in this case here, not a function. All right, so this is not a function. It fails the vertical line test that it's going to multiple y values. Let's go over to the next one here. So we have 2, 5. So we have 2, 5, 3, -4, -1, 2, and 4, 5. Oops, I already have 5. So I'm not going to write the 5 again. Notice that all your x values are different. 2, 3, -1, or 4 are each unique. So when you're looking at 2 to 5, that's cool. 2 to 5 goes just like that. 3 to -4, -1 to 2, and 4 goes to 5. Now, it's okay if the y value gets repeated. What we don't want is the x value getting repeated. So as long as these are all unique, that's going to be a function. Now, if we graph it, you're going to see 2, 5. Let me put that up here. 3, -4, -1, 2, and 4, 4, 5. So that's going to be over here. You'll see that there is, if I take a vertical line and I go through here, that only hits 1 point. If I go through here, it only hits 1 point. If I go through here, it only hits 1 point, and same thing here. So this is a function. Each x value is unique. Even though this y value got repeated, the y's being repeated isn't the problem, it's the x being repeated. So all the x's are each unique going to a y value, so this is a function. And then let's look at the last one. Why don't you try this one on your own and see if you can plot it and map it and answer the question. So go ahead and try this one on your own. Pause the video. And then when you unpause it, we'll check it. All right. So I have all the plots points plotted here, and looks like every unique x value goes to a unique y value. And notice that all the x values are unique. So it is a function, and all the y values are unique, which is not required, but that just kind of reinforces it. So you'll see every X and Y value is specifically unique. And of course, it's going to be a function in this case. So that brings us to this special case right here. When you see all the X values and all the Y values being unique, that function actually has a name. And that's called a one-to-one function. Okay, so this is actually a one-to-one function when you see every X value that's unique go to a unique Y value. One of the functions above is considered one-to-one. That is, each unique X value goes to exactly one unique Y value. That's going to be this one below up here. And one thing that you'll see is it not only passes the vertical line test, which is required for a function, but it passes the horizontal line test too. So if you put a vertical line test, of course, it's gonna pass the function test. But if you went and did a horizontal line, left to right, it's only gonna hit 1 point there, 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 and there. Therefore, it's gonna pass both the vertical and horizontal line test. That makes it one-to-one. So what I wanted to challenge you to think about, what would some graphs look like that could be considered one-to-one, that might be not one-to-one? Pause the video and see if you can come up with a couple sketches of your own. And after you unpause it, I'll have a couple examples that work for one-to-one and some that work for not being one-to-one, and you can discuss with your teacher or myself. Okay, I have a few examples for you guys to visualize what a one-to-one versus not one-to-one look like. So in the one-to-one category, something like a linear equation that has a slope to it, that's gonna be one-to-one because every unique X value will go to a unique Y value. Even this one where maybe the slope changes midway could still be considered a one-to-one because I don't have any repeating X or Y values. This set of points would be considered one-to-one because it passes both the horizontal and the vertical line test. So that meets the requirements there, and there. An example of some that are not one-to-one would be this one here. You notice that the Y value gets repeated there. So it kind of fails the horizontal line test. This one itself is a horizontal line. So pretty much the Y value is going to be repeated for every X value. And then here, kind of same thing, it fails that. So some one-to-one examples would be where you don't have any overlap Y and X, and then same thing over here, but you have overlapped stuff. Those would be considered one-to-one. Even something like this. This is not a function to begin with, but it's certainly not one-to-one because it fails the vertical line test as well. So these are not one-to-one, these are one-to-one. Hope that makes sense. Thanks for watching this video. The next video we'll be talking about evaluating functions and working with tables and graphs. Thank you.